Hi class. I thought I would do a video on our lab we are to be doing today on the foundation walls for the house that we've been working on in Granby. I know that my Google Meet was absolutely horrible last week, and again, I apologize. So I thought it might be better is if I just do this on a taped video, and then I can meet with you guys on Thursdays as well still, if we so choose, and go over the videos. I just don't have the right equipment or something. So anyways, I'm going to take notes and I will upload the notes along with this drawing. Excuse me, along with the video. You have the drawings in a folder in our estimating course shell on Blackboard anyways. All right, so remember with footings that we did our through walls, and then we did our butt walls that abut to the through walls. The through walls I classically do as my horizontal walls, and then my butt walls I do at the vertical walls. So I'm just going to talk through this video just like I would if we were together and on our live session, and start doing my calcs. So I'm going to start with my north wall, which means it's going to be the upper walls. And I'm going to zoom in a little bit here. Okay, so I have a couple walls that are facing north. I like to start at a clock-like formation and work around in a clock-like formation. So I guess I'll start over here on this garage wall and kind of work my way towards the right. Now, the footings, we don't have to worry about the hidden lines anymore, thank God, right? And I am showing these walls as an 8-inch. You could see over here on the right-hand side of the plan, I have an 8-inch foundation wall. Now, some of these walls are stepped, as if you remember on some of my lecture videos, we had that stepped foundation in this back side over here. And the garage walls typically are not full foundation walls, but these ended up being full foundation walls, full 8-foot tall walls. And then we filled in the garage space, this garage right here, with a ton of dirt, of course, that they're never going to see again, but that they had to pay extra for. That extra amount of dirt that I talked about had to go into the footprint of this garage as well. So that was some of the costs that they absorbed by taking the foundation and raising it out of the water. We ended up having to do full 8-foot walls in the foundation here. And then in this 4-foot crawl space, please ignore that note because that is no longer a 4-foot crawl space. And this opening here, we ended up going from this garage wall all the way to this back wall. We just left this wide open. So actually they could use this for storage. Again, because we raised it up so high, we ended up having to do full walls on these back areas as well too. This back wall that we're going to be working on is actually a it's 5 feet in the ground and 4 feet above ground. So our excuse me, no, it's not in the ground. I apologize. We brought the grade up, so it's like a 5-foot foundation wall, our footings being 4 foot below grade, and then we framed the rest of it. So I'll have to show you a picture of that when we get into the framing lecture next week. But trust me, this wall is only 4 feet, 5 feet of concrete and 4 feet of framed wall, or 3 feet of framed wall, for a total of 8 feet. Okay, so I'm going to start doing this entire garage wall. This is going to be a through wall. So I'm going from this edge right here. So that way I can use this. This corner is kind of tricky, isn't it? Because again, can I draw in here? Let's see. Yes, I can. Right here. So from here, come on. From here to here, this wall is gone. Sorry, I'm trying to see if I can thought I could draw on this. Fill sign, edit text and image. All right, but I want to highlight from here to here. Okay, whatever. It's not letting me. Anyways, on your print, if you can print it off, you can always just draw this line coming straight over, because again, this wall is not here. So I'm going to put an imaginary line across here right now. And that means that I'm going from this edge to this edge over here of this 8-inch wall. Don't forget, when we're figuring out our cubic square feet, we need 3 numbers to figure out cubic square feet. You need your length, we need the thickness of this wall, and then we need the height. So the overall width of this wall is this dimension and this dimension, which ends up being 24 feet, 8 inches. Also, don't forget, we have to use decimal format, right? Decimal format for all of our inches. And a quick way to do this is get yourself a cheat sheet online and be able to have it in front of you, or you can always just use your calculator and do the division. If I said these are 8-inch walls and I want the decimal of 8 inches, I take 8 and I divide by 12 for the 12 inches and I get 0.66666, or we can just say 8 inches equals 0.67. Okay, just to be able to get that dimension. And I'm writing this all down on my notebook, right? I'm writing this all down on my sheet. I have north wall labeled out at the top. And then over on the right-hand side, I have my decimal inches conversion. 8-inch equals 0.67. So I have 24 feet, 8 inches, or 24.67 feet times, it's an 8-inch wall thickness, so times 0.67 times 8 foot tall. And this is the garage wall, equals, I'm going to put garage, G-A-R-A-G-E, garage wall. And then I do the calculation, 24.67 times 0.67 times 8 feet equals 132.23. Awesome. So I have this wall completed. I don't know if it's because I'm doing the video, but I'm really upset that I can't highlight this wall to show that I've completed it, but whatever, let it go. Okay, next wall, we got this wall done, and I'm going to do this wall right here at the back of the mudroom. This one, it does start going down, so there's a certain point over here where it drops down to a 6 foot tall wall. I'm going to keep it at the 8 foot on here, and then I'm going to drop this wall and this wall on the right side and this rear wall to the appropriate size. But it's only a minimal amount of cubic square feet, and it's not going to break the bank if I just keep this as an 8 foot wall for ease of our calculations. We're just going to leave it at that 8 foot tall wall. All right, so we have the next wall at 14.8. So I'm doing 14.67 feet times the thickness of the wall, 0.67 times 8 feet equals 14.67 times 0.67 times 8 feet equals 78.63. So while you're doing this lab with me, you should be writing this out under north wall, writing it out in your notebook, and having your plan available, either printed or obviously on the screen. Okay, this back wall right here, I'm going to go from the right edge, and it's telling me it's 35.2 inches. Okay, 35.2 inches. This goes all the way over. So we actually, it's only giving us the dimension to this side of the wall, but we actually have to go over to the other side of the wall, don't we? Because we need to be able to grab that 8-inch thickness. So we're going to add 8 inches to this 35 too. 8, 9, 10 gives us 35 feet, 10 inches. 10 inches converted to decimal. I'm doing the 10 divided by 12 equals 0.83, right? 0.83. Okay. So for the third wall, I'm at 35.83 times the thickness of the wall, which is the 0.67. That is going to stay consistent throughout all of these calculations. And this wall back here, I said, is going to be 5 feet tall. So 5 feet equals. And you could always look at the cross section. Oh no, the cross section doesn't show it on this because this was after the fact. Okay, 35.83 times 0.67 times 5 feet. 0.03. Now, originally, as I'm doing this, I'm multitasking in my brain, which is never good. I'm thinking about when this was originally quoted. We quoted it as 8-foot tall walls because our assumption was that we were going to be able to go down into the earth a little bit more, but that did change. So he did save a little bit of money, as you can imagine. Instead of 8 feet walls, we were actually calculating 5 feet walls, we were actually calculating 8 feet walls, right? So there was a slight savings on that, but the way that we're calculating is the way that it ended up being, so we can see that true cost of what the concrete ended up costing, okay? All right, 3 feet. All right, so that's that north wall. We do have one more wall over here that I would like to add to my north side, which is that 4-foot dimension right there. We're actually going to go over, right? So we're going to grab this tiny corner in here where that beam is coming in. So we're actually going to say it's 4 foot 8 inches because I want the full through wall. This wall right here is going to abut to that through wall there. Okay, so my fourth wall, let me write on here, this is that little bump out. So this is 4.67 feet times the thickness, 6.7. And that wall right there was still that 5 feet tall because we wrapped around the corner. This whole wall's 5 feet, this wall's 5 feet, some of this wall's 5 feet, and it starts stepping back up as we get closer to the front. So I'm going to do this calculation. 4.67 times 0.67 times 5 feet is the 15.64, and this is all cubic square feet. All right, excellent. And that's it for the north walls. Okay, and all right, so now I know that this one's going to be the same as this one, so I kind of want to do my south walls. I'm going to do my other through walls right now and go right into my south walls. Okay, and the first one I'm going to do, I'm going to stay over here and I'm going to work my way over to the left. Stay to the right, work to the left. All right, so we know what this dimension is right here, those calcs, so just copy those down for this first south wall right here. This is the bump out rear on the back part, and this is the bump out front. Okay, so this is 4.67 feet times 0.67 times, actually this one, I apologize, do not copy that all the way. This one ended up being back towards that 8-foot tall wall. So please use the calculation of 8 feet on here. Let's see if you're listening to me. I said to copy it, but I just changed it up on you, so hopefully you catch that. 4.67 times 0.67 times 8 feet is going to give us a total of 25.03 cubic square feet. All right. Down to the front wall right here. This is another through wall. So we have, what do we have? 1310. So we're going 1310. So that's 13.83 feet times 0.67 times 8 feet back into the front at that 8-foot mark. 13.83 times 0.67 times 8 feet. 74.13. It's 1288, but I'm just rounding up, cubic square feet. All right, fourth wall. I'm going to use this wall right here as my through wall. So it's 3 feet from this corner to this corner, but I'm going to add the 8 inches so I go right through. So I'm at 3.67 feet times 0.67 times 8 feet equals 19.67 cubic square feet. 5. Fifth wall is this back bump out wall here where you're going into the front door above actually. So from, I want from edge to edge, right? Because I want this to be a through wall. So if I have 7.2 from inside to inside, I need to add 8 inches to the right and I need to add 8 inches to the left. The first 8 inches brings me to 7'10". And the second 8 inches brings me to 8'6". So I have 8.5 feet times 0.67 feet times 8 foot tall. Equals 45.56 cubic square feet. All right, and now I'm going to do the next south through wall. It's 1110 from edge to edge. So the sixth wall, this is the bump out front. Hang on, I'm just trying to make a note here. So when I upload this, you can try to follow through with my video and my notes here. All right, so the sixth wall is the 1110. So 11.83 times 0.67 times 8 feet tall equals 3 times 0.67 times 8 feet equals 63.41, rounding up, cubic square feet. All right, the seventh, we have 7 and we have 8. So we have 2 more through walls on the south side. We have this one and we have this one. This one right here, I'm actually going to keep it to the edge because this interior garage wall here is going to be much easier if I go right straight through, isn't it? I could cut it off here, fine, but I'm going to want to go right straight through there. So I'm actually going to cut this through wall right there. And that's okay to do as long as you note it. And again, I can't write on this silly thing. So note it either on your plan that, you know, create this line right here to know that you're kind of abutting this butt wall. Okay, so 12.2 from this edge to this edge, but I want this corner right here. So that's 8 inches. So I'm adding that to that. So that is 12.83 for 10 inches times 0.67 times 8 feet, because I told you these are all 8-foot walls in the garage. So I'm using true site conditions equals 68.77 cubic square feet. All right, last wall, 8. Number 8. So we're coming straight through at 1110. Okay, so 11.83 feet times 0.67 times 8 feet. 0.67 times 8 feet equals 63.41 cubic square feet. Cubic square feet. Okay, I think we have all of our, yes, we have all of our through walls. Now the fun begins. We'll do our butt walls where we have to do some deduction. All right, so I'm going to start with the east butt walls. Okay. And number one, this little tiny wall over here is actually facing east. So I'm going to include it on my east calculations. The dimension over here is 2 feet, 2 feet from here to here, which is fine. So I don't need to deduct anything from the bottom, but I do need to deduct 8 inches from the top, don't I? So this ends up being 1 foot, 8, 9, 10, 11, 12, 1 foot, 4 inches. 4 converted into decimal is 4 divided by 12 equals 4 inches equals 0.33 is going to be our decimal. So you have 1.33 times the thickness, 0.67. And that wall, we're going to drop down to 6 feet because coming around this corner here is where we started dropping down. So times 6 feet equals, and that'll help us a little because we did add on that back wall that 8 feet, and now we're dropping it down a little bit here, so that'll be fine. We'll still be a little bit over the original the end quote that ended up being, you know, because we raised this up and started changing the wall heights. 5.35 is what I got for cubic square feet on that first wall. Okay, so we grabbed that. This is no longer here, so don't worry about this in between wall, okay? Because this is now all open, I said. All right, over here on this right side wall, this one dropped down to that 5 foot tall wall as well. We have 16 feet. This through wall came through, so we're good on the bottom. We just need to deduct that 8 inches up here from 16 feet. So it ends up being 15, 15.4, right? Yeah, 15, get rid of that, 15 foot 4 inches, which is 15.33 feet times 0.67 times 5 feet tall, please. Equals 51.36. Again, I'm rounding up that after that second number on the decimal there. And third east wall, we're doing that bump out. So right side bump out. Just trying to give you some notes on my notes that I'm writing out as I'm talking here. Okay, so we have 12 foot 8 inches. 12 foot 8 inches. This wall does start climbing back up. This other one right here we did at 8 feet. So I'm going to go ahead and do this wall at 6 feet because it starts jumping up in this corner right here. We have 12 foot 8 inches. We need to deduct 8 inches from the top, and we need to deduct 8 inches from the bottom because this is a butt wall that's abutting to these through walls. So 8 inch up top brings us to 12 feet. 8 inches off the bottom brings us to 11.33 for 11 feet, 4 inches. Okay, 11.33 times 0.67 times 6 feet is 45.55 cubic square feet. All right. This wall right here, the front right wall here, let's see, we do not need to deduct our 8 inches here because that goes right across, but we do need to deduct our 8 inches from the bottom. So 8 inches, so we're technically at 16 feet and we need to do 6 inches more. So you're at 15.5 feet times 0.67 and back up to our 8 foot wall. 8 equals 83.08 cubic square feet. All right. What else? I guess all these other walls, we can face them to the west. Okay. So I think I'm done with the east. I have 4 walls. I have 1, 2, 3, and then this bottom one is 4. All right, very good. All right, so let's do our west walls. And I'm going to keep going in the same direction here as far as coming around, and I'll grab this wall first. There's no dimension here, but it's actually over here on the left hand side, the 9 feet. You could see that these two walls line up. So this is actually 9 feet from here to here. I need to deduct 8 inches off the bottom, but I'm good on the top. So I'm deducting 8 inches off 9 feet, which brings me to 8 foot 4 inches. Yeah, okay. 8. So I'm doing 8.33 feet times 0.67 times 8 feet. This is fun doing this while I'm talking to myself, videotaping this, but hopefully this will be a little bit easier for those that can't join us at that 3 o'clock time. 5 cubic square feet. 2. All right, so we got that one. So these little ones right here are 3 feet. I don't have a dimension on there, but they are 3 feet. We need to do our through walls, so we have to deduct 8 inches off the bottom and 8 inches off the top. So if you have 3 feet and you're deducting, yeah, divided by 12, whoops. What did I just do? 16, right? Yeah, 16 minus 12 inches gives us the 4 inches. So we're deducting 1 foot 4 inches, which is 2. So it's actually, okay, I'm getting tongue-tied here. 1 foot 8 inches, I believe. Yeah. 8 inches is 0.67. If I want to check myself, if I have 1 foot 8 inches and I'm adding 8 inches to that, I'm adding 1 foot. Okay, hang on 1 second. Okay, stop the video for a second so I could do my longhand subtraction. Oh, sometimes these lower numbers are harder than the bigger ones, aren't they? Ay, ay, ay. All right, so I have 1 foot 8 inches, and I actually have 1 foot 8 inches times 2 because these are exactly the same, aren't they? So that's good. So 1.67. Ay, ay, ay. 67 times thickness of the wall. 0.67 times 8 feet times 2 equals, because I'm going to do them both. You could write these out separately if you wanted to. I'm actually just going to multiply them both. 8 feet equals times 2 equals. So I end up getting 17.90 when I do them together. So this is 2 and 3. I'm going to call this. Okay, 2 and 3 on the walls. 2, 3. Okay, this one is number 4. Remember how I said we cut this one right here, so we're actually going to bring this butt wall right straight through. And we're not bringing it straight through to the back like this dimension tells us, this 34.6. We're actually just bringing it to the garage wall. So if you look over here, don't let this get you confused. Just look around at the dimensions that we have here, okay? We have this outer dimension of our garage from this outer wall to this outer wall at 25 feet 10 inches. So we know that up here, right, we can use that dimension right there. All right. And then this dimension down here, get rid of this little hand, come on. We have that 2 feet that's added here that goes down to that bottom wall. So we can actually add this 2510 with the 2 to give us 5, 6, 7 to give us 27 feet 10 inches. Now all we need to do is deduct 8 inches from this top area here and 8 inches from the bottom area. So I'm doing my longhand again over on the side of my notebook, and I have 27 feet 10 inches. Minus 8 inches from the bottom, let's say, and that gives me 27 feet 2 inches. And then I need to deduct another 8 inches for that top part of the wall, that top through wall, garage wall that's going through. and I end up with 26 feet 6 inches. All right, so everybody see how I did that? This through wall comes up to here, so I know I have this dimension extension line right here telling me 25 foot 10 to here, but I need to go to that other 2 feet because I need to grab this other wall right here at the bottom. Oh, Jesus, why don't I just move my cursor? Sorry. See where this 2 feet's coming from? See that extension line? So I want this part of the wall to this part of the wall. So that's how I got my 27 foot 10 inches. And then I deducted 8 inches from the top, 8 inches from the bottom, and I got 26.5 feet times the thickness, which is 0.67, times the 8-foot tall wall. And that gives me times 8 gives me 142.04 cubic square feet. Okay, great. So we did that one right there. I believe we have couple left. We have this little one here. We have our garage wall, and then we have this back wall right there. So we have 3 more to do. This dimension right here is 2 feet. We have this through wall, this through wall. So this is very similar to over here where we had the 3 feet, isn't it? But this one's going to be very, very minimal. So again, I'm going to do my shorthand over here on the corner. 2 feet 0 inches minus 8 inches off the bottom gives me 1 foot 4 inches. And then off, that was the bottom I said right here. And now I need to deduct the 8 inches off of here. So I'm minusing another 8 inches. And that's 4 to 1, and then 8, 9, 10, 11, 12. So it actually leaves me just 8 inches right in between these through walls. This tiny little butt wall is only 8 inches. So it's 0.67 times 0.67 times 8 feet. 0.67 times 0.67 times 8 feet equals 3.59 cubic square feet. Okay, the garage wall. This is, I'm going to say garage door wall. And this guy is 2510, and we need to deduct the 8 inches off the bottom, 8 inches off the top. So 2510, 10 inches minus 8 inches gives me 2, 25.2 minus another 8 inches leaves me with 6, so that's 24 feet 6 inches. So garage wall is 24.5 times 0.67 times 8 feet. 24.5 times 0.67 times 8 feet equals 131.32 cubic square feet. All right, last through wall, butt wall, excuse me, right here in the back. Okay, let's do this. 10 feet. So we have 10 feet. We don't need to deduct anything there, so that's great, but we do need to deduct our 8 inches up here. So that brings it down to 9 foot 4 inches. So 9.33 times 0.67 times 8 feet equals 50 cubic square feet. It did have some decimals on here, 0.0088. So we're just going to leave it at the 50 cubic square feet. All right, now is the time where we add all of our cubic square feet up so we can go through and get our cubic yards. How do we do cubic yards? We take our total of cubic square feet and we divide by 27 to get cubic yards. All right. So for the remainder of this lab, I'm going to have you work a little bit since you've listened to 35 minutes of me with these calculations. Hopefully you've written them all down. I did not tell you to at the beginning, but this is where listening comes into play online. You are going to add up all of the different walls, east, west, south, and north. I do them in sections, so I get one number for the north, one number for the south, one number for the east, one number for the west. And then I, just to keep myself organized, really, it's just, again, organization. And then I add those four numbers up. Those four numbers are going to be in cubic square feet. I get a total of cubic square feet, and I'm going to divide by 27 to get my cubic yards for the wall. Then at that point, once you get your cubic yards for the wall, I want you to use that multiplier of $2. Pardon me. Use the multiplier of $250 per cubic yard to get our total of materials and labor placed, we call it placed materials and labor of our foundation walls times the $2.50, times the $250 per cubic yards. No, it's not $2.50 to get our total of what this is going to cost. I'm going to have you fill out the rest of those numbers. I will upload my sheet that I just did talking through this video. So I will upload that. Please verify it. But I'm not going to upload any of the other numbers until everybody has a chance to watch this video and do this lab as well. I literally just did all these calculations. So you just really need to follow through with converting everything to cubic yards, and then getting the total cost placed, materials and labor, at the $250 per cubic yard. Fill out the sheet, finish up the rest of this, and that will be your lab for week 5. If you have any questions or concerns, please feel free to reach out to me, and I can review them at next week's lab. I'm going to be putting this on our lab 5, week 5 folder, so you can watch this video at your leisure. So I'm going to cancel our in-person lab today from 3 to 4:30. And again, I'm trying it this way to see if obviously you're going to be able to listen to it better than my live Google Meet. I tried to do a test run of the Zoom meeting that I said I was going to do, and I still ran into some problems. So I think this is going to be the best way to do it. Thank you for being patient as I work through these little things in the virtual learning world. But what we'll do is I'll do a video of this, and then maybe our Thursday lab can just be kind of a follow-up, right? A follow-up of any questions, or if you want me to redo some calculations with you, we can do that at that time. I think it's going to work more efficiently for those that can't attend that specific 3 to 4:30 time frame. Okay, so thanks very much. Good luck with the rest of your conversions on this lab and getting me a total cost of concrete. Thanks, guys, and I'll talk to you real soon. Okay, bye-bye.